Do the following. Number 1. Find the slope-intercept form of the line perpendicular to the given line and passing through the given point. Number 2. Graph the two lines. So notice that our given line is y equals minus 2x plus 2. So let's write down what we know about the given line. Notice that the equation has the form y is equal to mx plus b. So noticing that b corresponds with 2, that tells us that the y-intercept of the given line is 2. So we'll write down here that the y-intercept is the point 0, 2 on the given line. Also notice that the coefficient of x is negative 2. That indicates that the slope is equal to negative 2. So the slope of the given line is negative 2. All right, let's write down now what we know about the perpendicular line. We're given that the perpendicular line passes through the given point. So a point on the perpendicular line is negative 1, 1. Now notice that this point is not the y-intercept. The x-coordinate is not equal to 0. It's just a point on the line. We're not given the slope of the perpendicular line, but what we want to recall is that when two lines are perpendicular, their slopes are opposite reciprocals of each other. So the slope of the given line is a negative number. That means that the slope of the perpendicular line will be a positive number. So the slope of the perpendicular line will be a positive number. Not only will it be the opposite sign, it will also be the reciprocal. So it's the opposite reciprocal of the slope of the given line. And the slope of the given line is negative 2. The reciprocal of 2 is 1/2. So the slope of the perpendicular line will be positive 1/2. So for our perpendicular line, we see that we have the point negative 1, 1 and slope positive 1/2. So perhaps the most efficient way to write the equation of the perpendicular line would be to use the point-slope formula. So let's recall the point-slope formula. The point-slope formula is y is equal to m times x minus the x-coordinate of a point on the line plus the y-coordinate of a point on the line. So that's y is equal to m times the quantity x minus x1 plus y1. So our perpendicular line, will just substitute in the values that we know, and we'll get y is equal to m, which is positive 1/2, multiplied by x minus the x value of the point. The x value of the point is negative 1. And then plus the y value of the point. The y value of the point is positive 1. Now we are asked to find the slope-intercept form of the line. So what we need to do now is to simplify the right hand side so that it has the form y is equal to mx plus b. So let's first of all go ahead and simplify what's inside the parentheses. We have 1/2 multiplied by x minus -1, but subtracting -1 is equivalent to adding 1. We can now distribute the 1/2 through the parentheses. 1/2 multiplied by x is 1/2 x. And then we also need to multiply 1/2 by 1, and 1/2 times 1 is 1/2. And then we need to remember to add 1. So y is equal to 1/2 x plus 1/2 plus 1 is 1.5. Or if we write that as a simplified fraction, it would be 3/2. Remember, 1 can be written as 2/2. So 1/2 plus 2/2 is equal to 3/2. So the slope-intercept form of the perpendicular line is y is equal to 1/2 x plus 3/2. This is our answer to part 1. In part 2, we're asked to choose the graph below that shows y equals minus 2x plus 2 in bold, and also the perpendicular line. So let's first of all try to eliminate some of the choices. Okay, y equals minus 2x plus 2. We've already discussed that the slope is -2 and the y-intercept is 0, 2. So the first thing we might check would be to see which of the bold lines go through the point 0, 2. Well, it appears that A, the bold line goes through 0, 2, and in B, the bold line goes through 0, 2, and also in C and D. So all of the bold lines seem to go through the point 0, 2, so we can't eliminate anything yet. Next, the slope of the given line is -2. If the slope is negative, then the line must be decreasing. And we notice that all of the bold lines are decreasing except in C. In C, the bold line is increasing. So we can go ahead and eliminate C. C is eliminated because the bold line is increasing rather than decreasing. Now it appears that the bold line is the same in A, B, and D. And so now we'll go ahead and move on to the perpendicular line. The perpendicular line has to pass through the point -1, 1 with a slope of positive 1/2. We also want to recall what perpendicular means. Perpendicular means that two lines intersect each other at a right angle. A right angle is 90 degrees. Well, in part A, we see that the two lines are parallel to each other, so we can go ahead and eliminate the line in part A. So that leaves us with either B or D. In B, the two lines intersect, but it does not appear that they intersect at a right angle. In D, the two lines do intersect, and they appear to intersect at a right angle. So chances are our answer is D, but let's just double check and make sure. We want to make sure that the line contains the point -1, 1. So we start at 0, 0, move left 1 and up 1 and plot the point -1, 1. And then from there, the slope is 1/2. So we want to double check and make sure that if we go up 1 unit and over 2, that we get to another point on the line. And then go up 1 and over 2, we get to another point on the line. And we see that in fact D is the correct answer. B is out because the two lines, although they intersect, they do not intersect at a right angle.